Hello. Hi Subrat, is it audible?
Yeah, I can hear you.
Okay, perfect. Okay, we are discussing a problem statement. Let me repeat it. So one of us here had a real-time business case. Okay. So what is happening is their company is to get different mobile sets from different regions of the world. Let's add solutions to that. Okay, now you have to actually, the first stage is you have to gather enough information so that you are able to predict how much time will that particular mobile handset take to reach you. Got it, right?
Yeah.
Okay, so that is it. So if you have to gather it, the first question is inquire, right? You have to have you have to have multiple information. Okay, first information would be, okay, from where it is coming, which country it is coming, very likely, right? Then what is the target here? If you say the result is like receiving date, right? How many days it took, right? You can say that. Rather than receiving it, we'll take it how many days it took, right? So this is our target. Then what are other variables? Other variables can be your mobile number, right? Your mobile number, the custom, right? Custom and months, like on which month, right? Because based upon that, if it is Christmas month, right, it will be impacted throughout, right? True. Then other information can be, which item also, right? I mean, or if it really reached, okay, and that is very important. And it is a kind of sensitive item. It's normal. It takes 5 days or not. It is like an important document which cannot be. There must be some custom rules to scan it, right? Right. If it is a normal item, or if something, the bomb is coming, then they will. That kind of. Right. So the first phase is inquiring. I mean, you have to inquire all the possible information. The next stage will be obtaining the information. Like, you ask somebody, obtaining that. Third stage should be scrubbing the information. Okay, whatever information you got, you have to scrub it. Scrubbing means clean it. Okay, where you have to drop irrelevant information. If you have to make it a genuine call here, drop empty information. Okay, you don't have to drop. You actually have to take into consideration the fact items which actually didn't reach here. That is also possible, right? Many items get shipped and didn't reach here. Okay, didn't reach here, we got discarded in the custom itself or something. And which courier company or something? Which courier company? So if you take all this, if you gather,
how it matters, I wanted to know.
Which courier company?
Yeah.
Because if you pay $50, then courier will receive in 2 days. If you pay to $5, then courier will come in.
You default or but whatever we are getting the data models from Korea, that is they have fixed courier. So they don't vary with the courier.
Okay, then this is not it is fixed for you throughout, or there are multiple couriers there. See, if in a information, okay, if some variable is not changing, you can remove it. But if it's changing even once, that is a data to be considered. Right? If you are seeing the data set, you will remove. First thing is you remove the columns which are same. Yeah. If every day it is coming to FedEx, then no need. Yeah, that doesn't matter. That you can't change it.
And second point we discussed like Christmas or something. How does it?
The staffing changes. In Christmas, a lot of people are in leave because so people will be doing manual scanning and all that won't be there. And on this airline traffic, you are not the person who controls. It is over. It is controlled by the countries, by all these other socio-economic factors also. On that, you don't have a control. So you have to put it, and it has to be variable. It will be like you see a lot of US companies who have Indian base in December last week. There is no US representative there. So completely off. It gets impacted. And one more thing, again, price also, because if you send the Korean costly item. So maybe in the May month to do a travel to the US, the price is more. The summer people will be coming back and going. The price will be
these are test phones. These are test models.
No, I'm just giving an example. On your case, it might be a kind of on which date they are doing the delivery. Normally, this and courier prices changes. I think because of insurance value, courier prices changes with the price of the product as well. Not every phone will be the same value, right? If it is 20,000 rupees phone, then courier price will be more. More, and based on the weight also. Based on the weight. So a lot of things are there. I mean, if you by straightway thinking, you think, okay, what is there? But actually, if you think, start really thinking deep and all, I mean, these are the tools which will actually provide you, analysis beyond human understanding. You've heard about this classic problem, master, right? Beer and diaper. Did you heard? Okay, beer and diaper. I've heard it. Huh? Okay. You heard it?
No.
This is a very classic case. Yeah. Okay. How many people buy? Beer while they go for purchasing diapers. And vice versa. So this was a classic case. It's in the management studies they generally do it. That's the same category actually. So here, what do you do? There was analysis in Walmart in US typically to find out what are the relevant products. That means they want to keep the products close to each other, which one buy a person also buys the same person also buys the other product. Then they realized that among many other products this was surprised beer and diaper. People who bought beer also bought diapers. So human brain cannot think this. I mean, if I ask you, so what is the difference? None of us will be able to think it. So the reason was that generally, when married men drink at home there, okay, chances are high they have new kids. Okay. Second, if they have new kids and the wife was recently pregnant, she won't be able to carry huge diapers. So the husband generally takes it, and he generally takes it after office work. So generally, there is a tendency to pick up beer bottles after office work. So a lot of analysis around it, but yeah, there was an. So what I'm telling is, one very important aspect, right, which we don't really understand, or biologically we don't really understand, is as a data scientist, you should feel like every data is important. Even data that you discard is important, because if you're not discarding that data, it is impacting your result. Right? Have this sense. So even the discarded data is important, because if you're not discarding it, is impacting the result. So it's like every minute details you need to take into account. Right. Say for example, by default, if you say, I'm just trying to connect things which you really understand, which actually happens. For example, in take an example, house price prediction. You have house of prices of different rates, small house, bigger house. Logically, if you ask me, suppose if I ask you, okay, fine, I stay not very far from here, you have to find how much is the cost of that house in that area. What do we do? We'll see, okay, this is this square footage house. Okay, let me find something similar size, something near. You'll generally see this. But if you are doing this, what is happening is you are taking into consideration very small amount of data sets. Okay, so if you're doing this, you're taking into consideration very small amount of data set. You're actually null and voiding the data set which is small square footage pricing, right? So you will just see two houses. I think I have a very small diagram for this here. Diagram that I use from here. Okay, it's visible, right, Subrat? Okay, say I'll share, but yesterday I was trying to play that video from here. It was not carrying sound. Is it with my? I don't have actually any media player here. So I was just playing with the default. It didn't show so many sounds. So I'll upload it, or I'll share with you now. Okay, we can check if the sound is there. So I'm not very sure. Yeah. So see, suppose your house is in here, right? This is the house you want to sell. This is the square footage, is the price, right? Your house falls in this category. Okay. So you might say that my house is this. The house which is smaller to me is which price is this? Is the price which is smaller than me? This price is this. I think I will take average of it, and this data is sufficient to predict my house value. This is what by default we think. Okay, but in doing so, what are we what are we doing? We're actually, not taking into consideration all the data in this site. We're not taking into consideration all the data here, all the data there. So what is happening? We are actually not taking entire data into our equation. Okay, so this is something what we do by default, and this is something what system tells us to do. It will use this data also to predict the price of these house, right? So humanly, we might think that those data are not relevant to our product, but eventually it does. Okay.
So more data is better.
More data is better. More the data, better it will be able to predict that. So
one question. So let's say after 1 month or 2 months down the line, if some problem statement comes up, and if we see that the nature of this path is like kind of continuous and it's kind of supervised, then by default only it is linear regression.
Yeah.
We cannot use classification or regression. So
Right.
it has to come into this category. If it is continuous, some rule is like go
Linear
regression. And for that linear regression, if you do kind of more fine tuning, go to the gradient.
There are a lot of other techniques. Okay, so what you might do is I'll do this house prediction. So there are like you have multiple models provided by you. If you see scikit-learn library, you have multiple models. What is the thing you'll do? You will use the same data set. You will use all the models. Okay, in one function itself, there is a function that is known as cross-validate. This is a function inside scikit-learn library. We check cross-validate. Okay, it will actually validate for all the models. It will give you summarized output. This is the square mean error. Mean square error for all the models. You choose the best one.
So in linear regression, apart from gradient addition, there are some other.
There are some other aspects. So there is one greater. We'll see those terms. But gradient is something which we use more popularly. But it's not necessary that you'll always get right results with that. Okay, there is one more descent.
So there are also a lot of variations in that. Like based upon this one, let's say gradient descent is predicting, and in some other method also
Something will come.
Based on some variations, right? Category and
Right.
so we can provide those lists.
I can provide those lists. I have the documentation. I mean, of course, it is not possible. I have the
At least for
documentation.
knowledge based solution.
You should see. Generally, what we'll do, right? You will use all the models for your current data set. Okay, all the models, whatever you have, and you will run the case. Okay. First, you will train the model with all the models with the same data set. Then you have, you will cross validate all the models. Okay, so you know how much all the models is performing. Then you choose one. Right, got it, right?
Yeah.
So it's like brute force, but to certain extent it will give you result. Then you will realize that now what is the next? Why this goes by it? Then you can cross validate. So see, if you are into this, right, you will spend very less time understanding, to prove that algorithm works best for you. The reason is it is more time taking to prove than to test it because of today's infrastructure. Right, you can simply have a test case. You can actually do some basic sanity and all that. After that, you can run for all the models, get the results from all the models, and you can prove, okay, this model I ran for this thing, this is a test case. So going inside the algorithm, finding deep stuff is a very deep stuff. Okay, not everyone is. Go for that. It's never ending process. But this is not something that a daily life engineer would do. Nobody does that actually. You run different models. Okay, you in a one cross-validate function itself, you can pass different models. Okay, the way we create a logical linear regression, you can create few other options up here. Okay, do that. It will cross-validate entire thing. Okay, like later on you'll see these chain trees. Like you will cross-validate entire thing and then give you the summarized result. That is sufficient.
So it's like supervised, unsupervised, and semi-supervised. In supervised, let's say regression classification comes up, and in unsupervised, let's say clustering comes up. These are the three broad categories, and then this is subdivided. Linear regression again subdivided into cross gradient and all this.
One thing, keep it in mind here. So this depends. Okay, suppose you are given a problem statement.
Correct.
Okay, so so it might so happen that first you don't have any clue about the data, right? You are given some data and if somebody asks you, please, do some analysis on the data. Let me give you some example. You're given, you're given all the records of students. Some fields are given all the records of students of our country, and somebody asks you, okay, do some analysis on top of it. You'll ask them what analysis? What do I do? You take care of the data. You have the data. You give me some important information, important information. What you'll do in this case? How do you tackle this one? This is a very obvious problem, right? I mean, you have data, so what? I mean, what do you do? If the other person is smart enough to tell you that you have to do this, then it's a concise business problem, right? First is you don't know the business problem yourself. What do you do in this case? You use unsupervised, machine learning here, so that you understand the data first. So it will group certain data. Okay, student data, you will see, a lot of students from, urban places belongs to one category.
Oh.
Right. You wonder, oh, there is some other place. So it's not that, you use one without getting done. No. First, you have to understand. For that also, you have to do some, machine learning on top of it. You use unsupervised machine learning to understand what does the data look like.
If we are providing the data to clustering, will it work by itself, or do we need to provide still some inputs like, okay, this come together, please make it into one cluster? Do we need to do that, or
see? The first thing that we'll do. First thing you'll use all the parameters. Okay, and see, in clustering you can tell typically how many clusters you want, right? Or you may actually give, okay, you may start with n clusters and it can recommend you, okay, you need more clusters because data is some data you are seeing far from the mean of the centroid of the cluster. You might see that. So first stage should be, okay, let's group the entire student segment into broad categories. Then after you got one category, right, you have some relevance in that area. Then you might do some, do some analysis, some prediction, some linear regression, some classification there, right? First you have divided the data into broad categories, and you see, this, all this one. So you understand, okay, now I can create one classification urban student. I can create rural student. I can create, okay, middle class student. Now, you might think of those categories, right?
So that, like you are running one algorithm on top of another. That's okay.
Right. So your entire process will be, the first stage should be understanding. Generally, people use unsupervised machine learning for that. Understanding what does data look like, because it will give you some broad categories. Suppose, let me give an example. Suppose you are given movies, a lot of movies, data information. Then you say, okay, what do I do now? First thing what you can do, categorize the movie. I mean, not categorize, classic cluster the movie. This type of movies are seen. And say, these movies have some fighting and all. Can you be categorized into some action movies? Just giving a very lame example.
So block by block. That is the normal phenomenon.
So you'll now know, after the first stage, you'll know that, okay, you can classify movies, action movies, romantic movies, thriller, horror. Those things you will be able to coin by yourself.
And based upon that subset, I can predict, let's say, using the linear regression.
You can this is a classification. Yeah. Okay, so let's do certain things. Okay. Okay, right. So I think I just will run through few things, but I mean I have some picture which will be clear with this. Then after that we'll do the pizza problem. So this is what we are doing yesterday. What our model prepared is we were getting different values of W0. W0 is like beta 0, beta 1, right? Or Mx. This is the intercept beta 1. Theta 1. So you have multiple lines. Okay. So you have to figure out which one was the best. So this was the cost method. This is the cost function. Okay, root, this term will be changing root to root, top to top. But what is this idea? This is the actual value of house minus the predicted value of house. Right? Clearly, this is predicted value system. Right, and this is square of it. So root means square, sum of root means sum. So this is square of all these things. Right? Pretty much in line what we discussed. What we have to do is to find the minimum cost. So, right. So for finding the minimum cost, okay. if you find the minimum cost, we will found the best time which represents the data. Then yesterday I was talking about this quadratic equation as well. Okay, like something like this. We have only one variable here.
It's multi, right?
It's quadratic. Multiple variables when you have 5 also. I mean, theta. I mean, this is x is here, then y is here.
X4.
That is quadratic. Multiple is usually we say that beta.
Beta x, beta 2x, beta 1x, beta 2x.
Right. This is quadratic. Okay. Now, of course, this takes you to the problem of, if you can generate an x and generate this is a very important point, and I'll talk about how to measure performance before we go to the problem. So in this case, what you're doing here, you are creating more higher order polynomial. That means x square, x cube, x to the power 4, all those things are there. Using that, you are getting this overfitting curve. What is the problem with overfitting? It not being the best candidate to predict. Okay. See, your house may be here and it may be very low. So evaluating how do you evaluate if a model is overfitting? See, these things initially it will need more time to think, but later on will go faster because you would have understood these things. Okay. So what is the problem with overfitting curve? It causes bad prediction. Okay. So this is overfitting curve. And so what you what to do to test it? You divide the entire data into 2 parts: test data and train data. So you are using some part of the test data, okay, and finding the best model, okay. Then you are using training data to find the test error, okay. This is your score. Yesterday we were seeing score. This is your score because you are using score on different data sets. Okay. Now, this was your for a particular model. This is your model complexity. So generally, if you increase model complexity, what will happen? The error percentage will reduce. What is RSS error percentage will reduce? Okay. If you increase your oh, wait a minute. Are you able to view the slide?
No, I just can see the Jupyter notebook.
Oh, shit. Just a second, I forgot it was in extended mode.
Okay.
Just sometimes I may skip. I was talking about this.
Yeah, I can see now.
Just let me know. So I was talking about this test error and training error. Okay, you can see this is straight. I mean, why do you need this test error and trend? So that we can reduce overfitting. Okay, reduce the errors because of reduce the impact of bad prediction by overfitting. What you do, you break down the data into testing data and training data. For training error, we found the error. You found the best model based on training error. Great, but there is something known as test error, which we will do using test cases, right? And we found our test error this. So what eventually it boils down to is, okay, this is your training error. Okay, we see that for a particular model, this entire data is for a particular model, okay, or particular hypothesis. We see that model complexity for the training error, it is actually model complexity means you can say linear, quadratic, 13th order. The more model complexity you go, you more reduce the RMC, and eventually it may become 0 after a point of time, right? You'll see it if it is becoming 0. Now the test error may not be the same. Test error means it is reducing to a point. After that, it starts shooting up. Why? Because the prediction is getting wrong, right? Because the prediction is getting wrong. So you realize, okay, this is the best point at which the whatever complexity is this overfit. So the prediction will stop behaving. It generalization won't be there. Okay, understood the term, right? Generalization,
so
prediction.
In that case, you are saying that if the order is 13 or maybe better, then we should not be going for regression.
No, that's not what I'm saying. What I'm saying is this is different model, right? This is your linear model, this is quadratic model, these are different model. Okay, so what I'm saying is your model will be something like this. Here it may be raised to the power 6. Got it, right?
So when the order increases, the prediction is also going
bad.
Bad. So no need of
complex order. We can
that
stop.
kind of-
We should stop at that point of order where we saw the best results.
Yes.
Got it, right? It may be x raised to the power 6 where you're getting the best results. Right? Okay. So now this was one parameter. Of course, yesterday we were seeing adding other features like bathrooms and all that. So in that case, this is the diagram I want to show. So in that case, what happens is it adds one more dimension, right? It added this bathroom wala dimension. Okay, and you can see there's a hyperplane in it. So what does this is the last thing that you can imagine. After this, we cannot imagine. Okay, because this is the last degree to which you can imagine. Okay, so what happens in this case? There was a line which separated, or some complex line which separated beyond if something is falling far from this line, and we try to get the best line which matches all the cases. Here it is a plane, right? And if you add one more dimension like garden or not, it will be hyperplane, and there is no word of play. You call everything hyperplane. Right. So what is happening in one line? If the previous case it was one line, okay, so that line was representation of the current data set and future data. Now it is a plane because you are adding one more dimension. What is plane? It's a 3D line, right? So you are adding one more dimension. This is known as hyperplane. Okay, and when you have to represent such complex data, that's why NumPy came into picture. It can represent n dimension. Like every feature is a dimension of it, right? Okay, so other regression examples can be predicting salary. This is which done by which company? Glassdoor. Yeah. Right.
PayScale also maybe.
Huh?
PayScale.
PayScale is a company.
PayScale. I don't know whether it is a company or not, but PayScale also shows the same kind of thing. Right? What should be the salary for this and this.
Yeah, they actually.
PayScale is maybe it's like they can calculate only the average basis based on history data or something, right? This is the salary, like how much the company should pay to you based on your
Glassdoor tells
that kind of things also.
Glassdoor, I think, has a feature. If you can put your skill set, they will tell you what are you above market, below market, and you always get below market.
This kind of this kind of thing. PayScale also, I think.
So there is. I'll tell you one. There is two people who came for this. It is a company, HR company in Koramangala, something like that. So they are HR company. Why are HR people doing here? Then I realized they are not HR people. They are techies. And what they should do, they are developing a software using which they will predict how much hike employees should get. Oh, dear God. So they have various parameters, and they wanted to say that we don't want to blame we don't want employees to blame our managers. That is how we are selling the product. They want coming up with a product so that automatically by feeding all the data based on how much time you take to resolve the work, how much time, how much like some information it will take it from somewhere. Okay, which is just going to fill it. Okay, if somebody is not busy more in work and not filling it, I don't know what will happen to him. Okay, but if the system will itself calculate what should be okay. I don't know if it's good or bad. I don't think it is good for most of the people. Okay. So yeah, so definitely it is
a good company at least.
Yeah, managers actually nobody to blame them, but generally what you see in companies, people who do more work are less. Not less paid, of course, that is true. Second thing is, they won't be paying a lot of attention to filling these details, what work they have done. It's a very common scenario that we see, right? Okay, so let's get to the second problem. Okay, then you have stock prediction. This is, of course, lot of software are in this area. And if you're, claiming you develop a software and claim that the software predicts market. Predicts the market with 85% of accuracy. Trust me, you'll be within it because the demand of the software will be very high. Right? Not too many players can do that. And it's a very complex model actually. If you think stock market, there is not really any, there is a lot of thing in everybody's mind. If you see veterans in this market, what they think, what news is published, what is trending. So you see the number of variables are huge. I think it will be in order of thousands or 10,000, maybe more than that. I don't know. It's stock market. It's a very good area. Then tweet popularity. I think tweet popularity means if somebody is tweeting, if you want to predict how many retweets, how many other what are the like also is there in Bitret. Yeah, how many these things will happen? You can use this. Can you think of how? The earlier case is visible, right? You can imagine how. What about in this case?
I didn't get the question.
No, the question is this is like if you want to predict tweet popularity.
Yeah.
Okay, how do you predict that? If suppose you are tweeting or some cricketer or some famous person is tweeting, how many retweet you will get?
Based upon the
responses like
current trending stuff.
So you can see this depends on followers, number of followers, features of text tweet, popularity of hashtag,
Popularity.
right? So all these factors come into consideration. So based on this, okay, you should be able to predict how much retweets this guy will get. Okay, so this is if you see this is how the process would be. This is very important step because this is somehow the summary. See, every problem is there, not every solution is not ad hoc. It's a systematic solution, right? So what do you do? Describe in your regression model. You typically have to mention the input features and output. Okay, like output will be house price in our case of house prediction, pizza price. Calculate the goodness of fit metric. Okay, so goodness of fit metric is finding the RSS, root mean square, root R. Okay, estimate. Then you use the what is the other thing? What is it?
Theta 0, theta 2 minimize.
Yeah, you find the best theta 1, theta 0, 2, and this is your test data set, right? Then you have to this is a test data set performance of various regression models. Okay, not only one. You will use various regression models to find which is performing best. Okay, then you avoid overfitting, and this is the point I will introduce something else. There is a term bias and variance. Okay, so what we will try to understand, how do you measure performance of supervised machine learning? Okay, there is two very important terms to measure so that we are capable of measuring performance between bias and variance. Okay. Now that we understand overfitting and underfitting, let's now take it. Okay. You know the dart game, right? So we'll relate to that. So in dart game, okay, in dart games, everybody has to hit the bullseye. Okay, but suppose if that is the prediction. Okay, but if suppose there is a real prediction, but if suppose all the prediction is towards 3 centimeter away from bullseye, okay, all the prediction is towards that. Got it? Are you able to imagine what I'm trying to say? Like you have 3 circle, all the prediction is towards the third point. All the entire data is towards the third point. Okay, what is wrong in this case? The problem with this case is there is some wrong assumptions. Right? That means what is happening? Your most of the data is concentrated to some area which actually the model is predicting as centroid, right?
Peaking at the bullseye.
Bullseye actually. So what is there? Some assumption has gone wrong. Okay, this aspect is known as bias. The distance from actual prediction value to the mean value of entire thing, right? This distance is known as bias. Okay, when this is a situation where we get into underfitting. Underfitting, what suppose we are doing a very simple straight line. Okay, no matter what you do, right? All the data is coming, and all the prediction that is happening is far from the actual data. Right? That is a situation of underfitting. So we have to make sure the bias is not too much. Okay, first point. Okay, the second point is variance. Variance is it's generally mathematical word. Variance is generally your minimum and difference between minimum and maximum. in the entire data set, the difference between minimum and maximum, that is known as variance. To which, see, in that first case, the entire the entire dart was concentrated in one area. Now the dart is now the very one dart is at some point at the larger boundary.
In the 5 centimeter area,
Right.
other one will be then 1 centimeter.
Right. Let me show a dart so that I can. Right. If bias is when all the darts are hitting this particular area. Okay, so you say that the difference between this guy and the center of this guy, that is bias. And variance is one guy is hitting here, one guy is hitting here, one guy is hitting here. So that is making it large variance.
Variance is like we should consider like each and individual occurrences variance, right?
Hmm?
Variance we should consider based on each and individual occurrences. Occurrences means, for example, I am showing a data. He is also showing a data based on minimum and maximum score.
Right. We calculate it.
And in the bias case, like, we should consider only like what is the probability is coming.
Yeah. So what will happen in bias case? The model is predicting some output at some place. See, all are concentrated towards it, right? All prediction. So model is predicting some output in some other place. Let's see this diagram. The model is predicting the output some here. Right? So there is a solid element. No matter what you do, your data will actually, your model will start predicting here only. Its system is very rigid. Like if you imagine as underfitting line, no matter what you do, what you vary, what is the data, it will actually predict the data then and there. So that is your bias.
So bias is for single occurrence, right? Each individual occurrence.
I mean, everything is for individual occurrence.
But variance should consider as an individual occurrence or wholesome occurrence.
Acha. That is what you're asking. Okay. So both of them are wholesome. I mean, it's not for single data set. It's for entire data set. See, I mean, how do you say this line? Everything what I do is predicted to this case, because you will be able to say this and only when you are working on the entire data set. See, I mean, in the entire process, single data set does not mean anything, right? So it's just one case, right? So you need collection of cases to conclude something. So if you are predicting all the darts that is thrown up is ending up here, right? That will mean that the system is rigid, right? Model bias. So it is biased towards that output. It is not really fair. Okay, so you cannot have a system which is too biased.
And variance is like how much distance between from your mean. Let's say mean that yellow dot from there, how much distance you have.
See. Yeah, a model with high variance conversely will produce different errors for an input depending on the training set it is trained with. So remember, overfitting model is a variance, is a model with high variance, right? So no matter, I mean, the overfitting model is that curvy curve, right? So no matter what your data is, it can, I mean, there is no really sense out of it. I mean, one house with square feet 1000 and one house with square feet 1010 may actually vary a lot, right? Because it is overfitting curve, it can be anything. So that is a thing with high variance. So your model should not have high bias. Let's see here, a model with both low bias and variance. Ideally, a model will have both low bias and variance, but efforts to decrease one will frequently increase the other. Remember, I mean, when you try to reduce variance, that means when you try to make it generalize more. Okay, so these terms will be little related, but still little confusing. Okay, so when you say the model is overfitting, what will happen? The variance will be high. Okay, less generalization. Okay, so you make the term, that's why when you go to 13th degree, it is overfitting curve, but it is of high variance, right? At one, if you see this graph, see this graph. Here the price of house is this much. Here, just it's little bit change, a very fractional change. How the price becomes this? So what is happening? The high variance, right? So what is happening by increasing the polynomial? By increasing the polynomial degree, the amount of variance has really increased. You see this? By increasing the model complexity, the variance has increased, right? This is not the variance, so the variance has increased. That's why we see that even for a subtle change, you cannot really predict the output. It is gotten generalization. So your model should have less variance. That means if you are changing your data set, it should not change a lot, because that doesn't happen in real life. Got it, right? If it is too rigid, that means no matter how you are changing the data set, it actually not changing. Then biased. Okay, your model should have low bias, low variance. But the last line that is mentioned, if you try to increase one, the other will decrease, or vice versa. If you try to decrease variance, right? So what will happen? Your bias will automatically increase, right? That means your curve will become more rigid, right? If the curve is more rigid, you have to find this is the point at which there is a balance between both.
Ideal case is low bias, low variance.
Low bias, low variance.
So is there any concern or something?
Yes. There are ways by which you can mitigate low bias and variance. Okay, so fine. Supervisor will talk later, and let's see. So this method is known as, so yesterday we were seeing, right, regularization. Okay, so this is here what it does there. You'll hear this famous terms here, this lasso, which you see in documentation, right? Lasso. So these are L1, L2. I'll show you the references. So these are ways by which you can impact this low bias. You can achieve towards this way. Okay. So we'll come to this. First, let's do some exercises on this various type of regression. Then I'll come to this. Okay. There are three things I want to do today. One is we'll discuss in details what is gradient descent, doing the maths, whatever is required. It might require a little bit of calculus understanding as well. Okay. I might talk a little bit about calculus today, and I am very high level understanding. Next week there will be this class on statistics and all the maths that is required. That includes your matrix, linear, regression, probability, because that will be required during naive-based classification. So we have one trainer who will be taking this entire math stuff. Feel free to use this week to see what are the things that you want to do in maths. He will though cover everything that is required for the entire course. Okay, but the probability is what is probability, conditional probability, new base. So of a mathematical aspect, he won't be giving you a lot of insights about why it happens in Skype. That is what I will do. Okay, but this
is normal test and
will
all.
He will discuss what are the various sub-distributions, why do you use median, what is standard deviations, what are various types of standard deviations, when do you use it. So all those he will give you some references as well. But over this coming week, we can try spending some time. What are the topics that you want? If you want, you can mail me also. I can share with you. Okay, but
alternate hypothesis, all these things.
We'll talk about these things.
But we have class on the weekdays also, right?
Oh, you're having weekdays class as well? Oh yeah. I forgot completely. Right.
1 hour weekdays class. 1 hour weekdays class.
1 hour weekdays class. Okay. Then that will I'll take. This class will happen on.
So only 1 week. Next Saturday
he will take for maths.
6 hours.
6 hours. 6 hours. Yeah, around that. So he will cover. Yeah, actually, statistics is also required. So a lot of maths to cover in. So we have some exercises, whatever we can take on weekend.
Weekdays class, when it is going to be?
We have to yet. We'll discuss the timing during end of the class. Online, I guess, right?
Yeah, it's
online. Okay, so we'll fix some time which also.
To complete it first or any other reasons? Every from now onwards, how?
I think once or twice.
once or twice a week.
It's not that very rigid, depending on.
And this weekend class will go on. That is for.
That is. Yeah, that is most to. You might be solving some problem, and as well as some additional stuff. Okay, because if online, a lot of things will get really difficult explaining some concepts, so we'll do more of a practical. Okay, so let's take this. Yeah. So can you quickly load this stuff? I mean, everybody's Jupyter is online, right? Just load this stuff so that we can do. There are two types of regression that we'll do now. One is multi-features, one is polynomial, both of them, and see what works best. Okay.
Only these import sections, right? Only the import sections, right?
Just import. So now, yeah. Actually, now do this data frames. You don't need this. You can skip this part. Okay. Just do this. Create this pizza data frame. So that the information is there. Size versus pizza. So we'll use 3 models to work on this data. So once and for all.
Is there any software to run? Yeah.
Shortcut to so shift enter.
I've never used
This guy. No, now you should be more using this guy because it's very comfortable. That's what I feel.
shift enter.
Which is pizza data set. Yeah. It's a very small piece of code which talks about few concepts. Just to give little bit insight, this M dot is for the color of this magenta. Okay. And this is plotting the graph. 0 to 25 is x-axis, y-axis. 0 to 25. Is it a little not clear? See, these are forms next time.
There is the extra curly brace you have to do, right? After the price, the second line 62. No, before size.
No, this is a dictionary here.
That M is
Color. M dot.
M dot.
I mean, it says you want to show a dot. That's why the dot is there. Hello. Hello. अच्छा able to project, right? Any issue you are facing? If you are not able to project that map, inline map plot, it might be missing. It's working, right? Let's proceed further. So let's now apply linear regression over here.
Doesn't work, yeah.
Dot tab. Getting it? It won't work after you give. Sometimes if you give two or more options, one dot cascading, right? One dot, two dot. After that, it will stop working. Okay, so make sure you're ready in the next. COEF enter.
That model.coef. It is not coming.
If you just give model name, I think something.
Okay. I didn't run it. That's why it is not. Okay, now because I didn't run it. It takes some time to adjust.
But once that's right. Little bit initial thing it takes. It uses a lot of time. You can get coefficient intercept. Like this is the straight line.
My intercept is coming around 8. I think.
No, this is not intercept. This is prediction.
Yeah, my intercept is coming around 8. Yesterday it was coming around 1 point something.
Intercept. No, it is around 8, I guess. See. Okay. Now do a thing. Okay. Now evaluate the model. So for evaluating, you need different data sets, right? Whatever model you prepared above, you need time to evaluate that model. Okay. Though all these things can be run in single line, we'll see that later. But just display it. So what you have, we have a different data set here now. Right? Different data set. Okay. What you're trying to do, you're trying to find how does the model behave for this particular data set. Okay. So you can try this on this data set.
So here this 13.68 is the score.
13.6. See, what is when you're predicting, right? This is the pizza size. 13.68 pizza size.
It's literally an RN. You written the 0, then 81.
Yeah, after 12, why this is 0?
No, that is because it will return a. So that I need to execute the entire thing. So there is a way by which
Using that 0 also, I don't know. It's coming.
without 0. Yeah, it will come a tuple.
Okay.
If you see the output is a tuple, second argument will be nothing. First argument is your data. So we just needed the first argument. That's right. Then if you just try without 0, it will be.
No, why that 0 is
0.
FLT.
Its kernel is running. See this, if I am giving like this, you're getting this content, right? So if you want to get 0th content,
Okay, to avoid
that because it will come list, I mean inside a list data set, right? You need only the internal one.
you just okay.
Okay, because you need
But
to.
if there are multiple,
Then you have the entire data set.
So
If you want to use multiple, you can test it like this, right? You will get different data set, right, to predict multiple test cases. Now let's.
my question is why we are providing two.
Right. So understand this thing. This fit SkyKit, entire SkyKit. Okay, the entire SkyKit actually takes. If you see the argument of fit predict, it takes list inside a list. Right? Why this is because here we have only one parameter in this size. It can be multiple parameters. Size is one parameter. It can be more other information. So it is always list inside. In prediction is also you are predicting one thing as of now, but you can of course have multiple things. So that is where you can have multiple data as a list and all. This guy comes here. This guy comes here. You just make sure that internally, no matter how complicated things become, it is represented this way. So entire SkyKit learn uses this same.
Only that means you just need to know how to fit that syntax,
Right.
and how to evaluate and how to see the output.
And you should know what are the possible models to test the same thing. You can actually treat the mathematical. I mean, if you know it's good, and you should know a little bit of things around it, but it is not possible to know all this stuff. Okay, you should know the process. Like any product, if you're working on say telecom product, not necessarily you deal with those that signal range. So those are the important things. But you just know it, that's how it works. There is a frequency, there is something like that. That understanding is okay. You should know how to evaluate various models. So that is the major work. If you say any work, it is like, see, you have a lot of computation for it. It's not that if you're evaluating something, you have to pay money for that, right? You evaluate something for various models, you'll see, which thing is fitting here the best curve, select it, it will work for you. Pretty much this. Okay, now let's do evaluation of the model.
Even if we are using single bracket, is providing the value with some warning.
Yeah. It is, and later on it will show error also.
0.19 that.
In some cases here, when you use feature, polynomial expression and all that, you will not accept error. Okay, so I understand that throughout SkyKit learn, the input will be taken in, list inside a list. Output will be given list. Okay, next thing is to find the score. Okay, you can do many more things. Take this as data set. Later on, what we'll do, we'll pull down. I mean, the code will be here. You can pull down the code and start executing line by line. But initially, it's good to write it in your hand so that these small double brackets we understand that. See, score is similar to, right? You need a different data set. What will happen if you use the same data set in score?
100%.
Right. I mean, now it won't come 100%, but if you have a really high order polynomial, it will come 100%. Now it won't come 100%. It will be around 90. You can try that also. Do that as well. Okay. Use the current data set to find the score, and use a different data set to find the score again.
You are saying it will not provide 100%?
No, it won't come because it is a straight line. It will be very close to 1, but not 100%. Like, what is our previous data set? See, it is coming very high, 9.91%. Not 1 because it is not high polynomial, it is a straight line, but still it is very high.
On the same training data.
Training data.
The test data is coming as 59.
59.
Why mine is only 0.07? The same data, same.
Which one? You're using this data set?
No.
The training data set?
Training data.
You wrote that. No. Predict. Why? There is something wrong with your input data set. I guess your prediction is also wrong different for this time.
It is the same values.
It is the same data.
7, 9, 15, 11, 12, 18. Yeah, correct. No, before that, the other values were also same. This value only 100.
I mean, the reason why use data pattern should be something like that, because in real world, data won't be very much abstract. One data won't be very much different from other, right? If you are doing the it may so often pizza building has gone wrong. Okay, how can a big size pizza priceless? If it is happening, that's the first thing. I mean, first you do is project graph. See, there should not be a lot of outliers, right? So there are, later on we'll learn how to remove outliers. This is a very good case. Okay, so see, if you have a data set, okay, and if you have few outliers, some pizza you are giving it dirt cheap for some reason, okay, old stock, okay, giving dirt cheap some pizza, but you have to make sure you remove them from your data set, because that will impact your generalization. Understood, right? Yeah. So there are techniques to do that. Okay, there are standard techniques.
Techniques to remove the
techniques to remove data. So it is all technique game. If you know the right technique and if you can apply the systematic right techniques, it will pretty much solve 80 to 90% of the problems. For less 10%, you need different skill set. So that is it. You got something wrong? Nice. Let's see what you other guys continue writing this. Or if you want, then everybody of us can debug. Which one?
4 5. There is some syntax.
I tried with dot also.
Dot why it is coming 11? I mean 12. Oh.
It comes
13 actually. It comes 13. It has come down. Generally it goes up. 18. Yeah. See, there is an outlier. Good. These are the mistakes you should do and we should do. Okay, this is the outlier case. Because of that outliers, your entire model is now skewed actually. So I don't have to show an example there. Right? Everybody remembers this case, right? So what happened in his example, he took this first data as age. Okay,
last data.
Sorry. In this case, In place of 18, he took as 8. So what it impacted for a huge Caesar, the price has impacted. Now his curve was like this. His curve was skewed. It was like this, and large data was like this. And since the data set is very small, it actually impacted. And his prediction was going very bad, right?
My bad.
No, you should do this. I mean, that's why the importance of doing mistakes is very important in learning. Go on training data set. Invalid. So is it double bracket that you're missing, or then that is a mistake?
Print pizza underscore price underscore model dot score. After that single bracket pizza double square bracket size.
So your test pizza in structure is right. Sure. I mean the contents, number of elements, number of size and price are same.
Yeah.
Will comment second line. This was
The footprint it is over.
Is it Python 3 that you are using? Python 3 you are using, so bracket.
Okay, inside print after print.
Yeah. Or how do you make same code works for both Python 3 and Python? There is something known as import future.
Okay,
you must have seen it many places.
Yeah,
Import future from import future, and from future import division print. You can do that. That is a way to make sure the same code works for both of them.
In Python 2.7, you will write those.
No, in both of them you can write. Import future. Yeah. You can refer to the import future.
I think I also made some problem in the score. It is like minus 1.3%.
Minus 1. I'll let the experienced guy go.
I used to give it 77. No. Your test pizza, your pizza.
So both of them are different, huh?
Yeah.
Okay. Yeah. Now, what you want to do is you want to do the prediction.
So what we want to take data whatever we are providing right for scope. That should be created by us or this should be
No, this data will be provided from external sources. I mean, you need some genuine data. If you have some, I mean, you can of course use data, but you need some genuine data. So there are in scikit-learn there are inbuilt data stores also. Okay, so let me show. So if you do something like this, there are a lot of data sets, inbuilt data set itself. Yeah, do this, huh? Import SQL dot. See, you have this California housing data set. Inbuilt, yeah, a lot of data sets. I mean, you can use. Yeah. Get data home, load Boston breast cancer data to identify whether something this is used in classification. I don't know, diabetes data, load digits. This is the image stuff. So handwriting digits, right? You will try to identify which number is it based on your pattern of writing, right? So you have a lot of these data, so you can play around with it.
Titan also will be there.
Load digits, load file, load iris data, standard data, right? The data is here. You don't have to do. Right. ML sample images, SVM write files, logs, classified, modes, multi. So you have a lot of switch here. Okay, so a lot of these test data you can just try around. So we'll use a few. Okay, let's come back. So everybody is amazing. So now what you can, there are a few things we can do. If you want to, this is a very common thing. Okay, it's a very common thing you want to test for all the data. You want to project a line, future line. If the pizza price changes to this at this future point, what will happen? So you can actually plot a graph based on the line. Now it is a straight line, so it will of course, and if you, I think, change it like this, it will come. So this plot, right? There is one scatter graph, is one option. There is one bar, I guess. Let me check. Data set is. No. This is because the previous lines are not executed. To execute the previous line, learn cells, learn all above, so that the entire thing is loaded. Oh, this is yesterday. We fixed it, right? Right. Yesterday. Yeah. So now if you have other option also to show. You can create a straight line sort of PLT, right? Bar. A line. Grid. Oh. Bar. Test pizza size. Test pizza price. To see if the syntax is right now. Okay, we'll see this bar. and provide that straight line. So see that anyway. So
How that even goes out?
they execute the right way. Yeah. So now let's try doing this multiple fields. Okay. What we have here is we have here multiple fields. One more feature. Just try doing the same thing with this multiple fields and see if you're able to predict that better or not.
Adding
One more fields. Okay, this is multiple feature. Then the next thing would be we'll try with polynomial integration. There few new things will come. What new things will come? We have to create. You can see here. We have to create. We have to create. You have to create this thing, something like this, polynomial features. Okay, using that polynomial feature, we'll be, training the data set. We will for like, how do you really understand like a is equal to bx was on data? Now it will be a is equal to bx plus cx square. How do you do the maths? How do you do? So these are the things you'll understand now.
Okay,
Degree, how to do that? How internally matrix thing actually maps in here? How the entire thing is, those all things we'll understand now. Okay, we'll take 5 minutes break. Skip copy, and you can try doing this if you don't want break. Because there is you can try this multivariable search. Just use this data set. After that, we'll do this expression. Yeah, this is the topic. So see how to compare. You have to compare two models now. Okay. 5 minutes later. So,
To save this notebook, I have to download it.
It will be saved.
There is no save as option.
No, it's not able to save. It will download it. I mean, it will exist.
Untitled now. That's why.
Oh, no, sorry.
Yeah, it is.
The name will be.
How you are saving these screenshots?
It will automatically save. Oh, image. Oh, you can write HTML code inside it. If you make it markdown wherever I'm writing comments, then image src is equal to image path. There should be some cloud path. Taking images
From the desktop itself to take it.
No. That's why I don't know. I'm looking for it. But you have to put it in cloud. It is not drag and drop. It should be, I think. They should get it drag and drop.
5 minutes, right?
But taking
Control list.
Untitled. ऑटोसेव से ହେଇଯାଉଛି ନହେଲେ ଏଠି ଫାଇଲ ଭିତରେ ଯାଇକି ବି ସେଭ୍ ଆଣ୍ଡ हमें रियल टाइम उत्तर करना पड़ेगा ये छोटा छोटा ये उत्तर Game मुझे पता ये देजी मतलब इधर गाड़ी आ गई
एक भी किसी नहीं से कमेंट कर रहा
कमेंट डाटा है से ठीक से डाटा नहीं
है
कि गवर्नमेंट को
डेटा डॉट जीओवी डॉट
और डेटा डॉट जीओवी मेन बड़ा डेटा करेगा
बड़ा डाटा मिलेगा आउट वेबसाइट क्वांडल QUANDL खराब होता है यूएस डाटा
टेस्टिंग के लिए बोला
ये आंसर डिपेंडेंट डेटा
it has a multiple linear no
तुझे लॉक करने की पड़ेगी ये चिड़ा और ये नहीं हो सिक्योरिटी और
Butter.
ये भूल लिखी था लास्ट तक पिज्जा न्यू टेस्ट वाला पिज्जा न्यू मॉडल लाइन 99 है ना पिज्जा न्यू मॉडल ले हमें पिज्जा न्यू का दो पिज्जा न्यू टेस्ट दो ना स्कोर तो करो जा पिज्जा न्यू टेस्ट दो ना ସେଟା ଭୁଲ ଅଛି ତାପରେ ଆଉ ଗୋଟେ ଭୁଲ ଅଛି କଣ ତ ପ୍ରାଇସ୍ ଯୋଉ ତା ଉପରେ ଲାଇନ ଦେଖ ଲାଇନ ଲାଷ୍ଟ ପ୍ରାଇସ୍ 11 8.5 15 ପରେ ଆମର ଦେଖାଯାଉଛି
पूर्वी को
ସେଇ ଲାଇନ 99 ର ଲାଷ୍ଟ ଦେଖ ପ୍ରାଇସ୍ 11 8
साइड कर दो
एक साइड कर दो
नॉले किसी का वैल्यू नहीं
हां किछ माने हमरो माने तार तो भूल अछि 99 90 पटे लिख कर कर दीजिए ओके 15 18 No, no choice. Muy bien.
ahorita no apuró la línea ahorita se keyboard rate Nixon no parece aún एट पॉइंट फाइव नहीं था
तो कितने वो माइनस 6.5
नहीं सीधा 8.5 है
हां राइट
just seven
तो पिज्जा न्यू टेस्ट इक्वल्स टू
pizza new model dot score pizza new test size topic pizza new test price
more minus support पिज्जा न्यू मॉडल और पिज्जा न्यू पिज्जा कौन लेते 6 8 10 40 18 ना
तो से जहां लिखा है मैं क्या कहूंगा
ऑफर 28 में এটা ভুল লিখছো না সারা এটা টিচার এটা ক্লিয়ার সরি এটা টোটাল ভুল লিখছো একটু কপি हम उनको बस करते हैं सर साथ में नोट देगा साथ में नोट देगा 17.7 लिखें
भूल डाटा से हम भूल गए
तुम्हारे क्या भूल है लास्ट लाइन पे सबसे भूल है पिज्जा नहीं टेस्ट हो
हां
77 है हां 77016
ओके अब मैं ये कर देना
प्लॉट करेंगे
ना मैं टेस्ट भी बाहर कर रहा था ना मैं प्राइस तो वैल्यू हमें पाई है एबे हम तो स्कोर कर स्कोर काट दो किंतु प्रेडिक्ट वैल्यू कर रहा पड़ेगा
what is happening? Prediction is not working.
नो
yes score is now 77
Regular, huh? From 0.59 it came to 77.
Actually, there is some
There is a mistake in the last slide. You have kept it as pizza new. It has to be pizza new test.
Right. Is an interest. Yes. Pizza new. What is pizza new? Pizza new. Acha. Right. It is your.
Previously it was 59, now it is 77.
My pizza new. Acha, I don't have a test data here actually.
No, you have kept it in the table again.
Oh, here it is. Okay.
Instead of pizza new,
Hmm. 77. Okay. So you have multiple features now, and based on this multiple feature, you're predicting.
if I add more features, then it will start. It might go up, go down.
Might go up, might go. So we don't know. We can only know this only when we are actually doing it.
So on this case, so who will take the final call?
You. And based on the value score that you see here. This is the best proof. See, I mean, these all are mathematical models.
Right.
Okay. If you do the other way, so these are, why data science is many popular now. Okay, because now mathematician also can prove their things. Boss, I was right. No, I was wrong. This is how it is. That is the reason, and these tools are making it too easier. The data scientist, actually, if you search data scientists like 10 years back, they were only mathematicians. Okay, stats are minimal. There were no computer science involved over there because these tools were not developed. Okay, these tools are not very old actually. Okay, a couple of years, 3-4 years back. That's it. Now what has happened because of these tools? Okay, you can easily prove your mathematical model, right? So that is what you are doing here. You are just somebody has written the mathematical model. You're just finding which model suits you the best based on some understanding, and you are using it like this, right? So everybody is comfortable with this two feature. How are you testing the two features, right? And we can use other inbuilt data set.
Okay,
Or I'll give you one exercise this weekend. You're asking something?
yes. Now I want to print the the price which we have given, and I have to plot it and with the predicted values. I want to plot both the values in one.
That you can do easily. I'll show you. The previous, sorry, come again.
The training data output as well as the test data output.
No. The new test data, the price we have given, right? So that is the actual price. And predicted price, we got it. So I want to plot both so that we can see how it.
Right. So I actually have done it. Use this process. Something like this, right? So what do you do? Whatever you use your data set, just mention both of them plot, and just give a line style. That was what I was doing last time. Line style. Okay. The line style do this. One will come like this. Another, if you don't do this, it will come straight line. Got it, right? Just merge both of them. Plot. If you don't give anything, it will come line, blue line, and the other one you give this thing, line style, and see red color is equal to red. These are from same office or different? Are you two different? You both are in same office. All are different office. If you guys are in the same office, then you can have some tea, some break time common, and you can actually discuss that. Okay.
So inside plot, you can give an entire.
See, inside plot, just pass x-axis, y-axis,
Right.
and it will plot you normal straight line. Got it? Both of them it came, right? Okay, so that's Okay, both of them came. Yeah. Oh, nice. Everybody can see this. Actually, you have some projector. Your prices is coming down.
SDN, right?
You need normal, no?
Yes, it's price. Well, you set it up.
No, it is not working. Okay. Why it is coming down? Maybe larger pizza has some discount.
No, this is the value which you have given. It's exactly we have given. See. What is it?
Oh, toppings is also there. No?
How to? I don't have anything to track with.
That's okay. Got it.
Yeah. 8.5 we have given the price, and the output what we.
Oh, toppings is also there, right? So maybe some cheap toppings if you put, the price is coming down.
The value we have got 10. It's not that much difference, but in figure it is showing like this. See, this value is 8, another is 10.
That's why you see a lot of.
It is 8.5. This is 10.
So what is this blue line? What is this green line?
Blue line is the actual value, and the green line is the
predicted value. Right. It works. Okay, so got a comfortable feel, right? How do you test various models? How do you do that? So now let's see this polynomial regression. So few things to be noted here. Okay, so as of now we are seeing sort of a straight line, right? And based on the prediction values, we are seeing all the data system. Now we will use polynomial, so the lines and the curve can be more curvy and it can be more, more fitting. Okay, because now as of now our data is under fitting, and we have less data, so of course. So for this, what we need to do is we need to use this polynomial features, right? From sklearn pre-processing polynomial features. This is your current data set. This is the size. This is the price. Okay. Now what we are doing here, this is our norm. I think. Yeah. This is our normal data set, normal regression stuff. Okay, you know linspace, linspace, and what is doing 0 to 26 is generating some 100 data. Okay. This is your x. Convert into something that is fit can understand. Okay, so what you are doing here, this is an important line. Xx dot reshape, xx shape 0. What is shape 0? What is the output of this? The output will be 100, comma 0.
No, 0 to 26.
So what is the dimension of this?
100.
100, right? One dimensional array, 100. Okay. So 100, comma it will be. So you want to get the first element out of it. You want to get 100 actually. If I print here, I'll have to execute. Actually, I would have this run too. It's very fast. So if you do this, xx dot
Say we have to give parameter.
no, I don't want to reshape it. I want current shape. Why is it not showing anything?
It is an attribute, right?
Yeah, here it is coming. See, shape. So you're getting 100L.
Nice.
Nice. Okay, so I want to use this 100L here. Okay, and I want to create. See, it needs a list. So there are many ways to do this. So this is the simplest way to do this. Okay, what are you doing? You're reshaping it into 100, 1, so that it forms a list inside a list sort of data structure. because that is what fit understands. Remember, we are directly doing from pandas, we are doing double bracket, but here we have to do this shape 0 so that you get this 100th number, comma 1. So if I print, see the way the value is coming here.
0.
See the how it is, how we are coming in. Shape of 0 is this guy, 100L, right? You want 0th element. 100L. So it is like 100 comma 1, reshaping it to 100 comma 1. You are converting that into list of lists. Right? This is the smallest code to do that, rather than actually looking through all that stuff, converting.
So we are just generating random numbers, right?
No.
Get that from that.
Linspace is generating numbers between 0 to 20, generating 100 numbers equally spaced between 0 to 26. Okay. So now here you're converting that entire data set. This is the list. This is the list of numbers. You're converting that one-dimensional list into two-dimensional list.
in cross.
And cross, right? That is how you're doing it. Okay.
Okay. Before resetting, can you show us?
Yes. I think that is what is required. You see one-dimensional data. Okay, so he's because your fit only understand two-dimensional.
Is a single list. Basically, we're creating a multi-list format in a dimensional.
Right. So that is one of the easiest way to
So
do that.
this time we can directly convert there itself, right? Using list bracket.
Double bracket.
No, list single bracket and
But that what will that will do? That will create list inside a list. You need all the numbers of list inside another list.
By creating list inside a list. In that case, we can also plot.
We can also do that. I mean, right. You can actually, when you are mentioning this data, like in Evo case, right? Like, okay, this is data frame, but if you are not using data frame, you can do something like this, right? D is equal to 1. This is what you're meaning, right? 2, right? This is also valid. This is also valid. But you will hard code these to few numbers on. And generally, you won't get data in directly this format, right? You can convert.
For example, we are getting XX, right? Like we are getting XX. So what I'm telling you,
XX bracket.
Just give this entire list bracket XX. It will automatically take that format.
Or you other sync. You do it or not? If you do like this, list you're saying
List of X.
It will convert to
like this.
It will convert to
No.
It is converted list.
now after converting that list.
So two things that is happening here. 0.0.2. So it is converting the entire thing into list.
Yes. And
Each element should be inside a list.
from my point, I understood that. Second point is, if we are converting the single list, the single list platform, so do we plot or not?
See, the first point is you should not convert NumPy into list. You know what is the difference between NumPy and list?
NumPy is array, list is like.
Why the invention of NumPy was invented? See,
Okay, I got it.
Huh?
I got it. See, for example, if you are creating an array, right, the plotting is based on the pivots. Normally, as per the normal plotting scenario, plotting should be based.
Forget about plotting. What was the basic fundamental question? Why do you need NumPy when you have things like list? Why do you need it?
Because of the code, because you're getting the coordinates.
NumPy is the scientific level make it faster.
Why it is fast?
Because it is you can access the list means you will traverse each element.
It says an array-like structure. That's why.
That list also does.
But you can directly go to the, let's say, 5th point, 10th point.
You can do that in list also. You can bracket and then directly index. Why do you need NumPy? And why it is faster? You know how much fast it is. If you want, you can compare. You know this percentage time it to find the performance of a number. You can try this stuff. So, and why it is faster? The first thing is NumPy is faster because it is holding data the way C does. How does C store data? C stored, if you are creating a array of integers, C actually allocates integer. How does list do it? Reference to integer. So that is how list does it. So that is pointer kind of a thing, because it can hold heterogeneous data, right? So each size of each data can be different. So everything is a pointer over there.
But
So
in list we are not calling any pointer. That means we are not
that is,
calling the address.
but when you are doing like list bracket 1, internally that is getting the object which is pointed by this first position of the list. So it is by reference. List is accessed by reference. It is great in storing heterogeneous data. But the problem that you face it, for every element, you actually have to access one address, go and find that value, right? And that can be some different memory. So when you are accessing one memory to another memory, what is happening? You are doing context switching, right? You may have to go to different page memory, so it is not fast. Okay, so you have data structure like NumPy, which is holding homogeneous data in non-continuous storage. Okay, so understand, is this all NumPy internally is written in C and Pascal?
And it shows the physical value. No, not the address.
Not the address, yes. That is why it is faster. And that is why you should, when you're writing the code, the objective should not be, converting it to list, because that will devoid the purpose itself. Okay, you should make sure the entire thing is in NumPy.
So list stores reference while NumPy stores the exact value.
Exact value. Because that's why it is, the reason why being homogeneous is not a negative aspect. That is why it is intended. So that is why you can achieve it. Okay.
So in this example, we're converting each to one list.
Each element to one list, because your stuff understands only a list. See, XX is your data. So what are you doing? You're doing a prediction over here. On current model, right? You are doing a prediction over here. You are converting that into this data, right? And finally, you are plotting the graph. So it is plotting the graph between 0 and 25, 26, and 100 elements are plotting this graph, right?
My question is why we are converting into list one.
Because it only understand the list. It doesn't understand the elements, right?
No. His question is actually, if you read the question, so why does in fact Scikit learn mandates you to pass list of lists? That is a thing, right? Yeah. So see, in this case, we are using one parameter as one feature. How would you pass multiple features for a particular test case? Is there any other way than passing, apart from passing list of lists?
No.
See,
that point is clear.
That point is clear. Right?
But why we got 100 values? Why we converted it into 100 lists?
So the reason is, see.
Okay.
See, this is one value, right? If you can have multiple feature values, how do you pass multiple features values together? We need some placeholder.
So if it is a list, then we can pass.
Right. That is why you and it wants to maintain same data structure throughout. That's why when it is predicting the data, it is giving you list of lists. So that if you're using it for some other input, you don't have to do the also list. Okay, generally you will see this in most of the parallel processing system. Input and output will be of same data type. You see Hadoop also, the input output is key value data set. You see Spark also, it's RDD. Right, more or less it will be of same type, so that the output can be used as input to some other function.
So what is RDD?
It's actually, it's Spark also. RDD is like that is a flow. Yeah. So it is like a virtual object which represents the distributed object. Yeah, just it is an object which is a representation of distributed object. What is distributed object? Like the data is broken down into multiple pieces and stored in different systems, and you want a representation of it. So whatever you do on the representation is actually being done on the other data sets.
Okay, read and write, everything will work if we do something in that concept.
Yeah. So it is like representation. Like, for a particular, you have a representative candidate. So you hit that person, he will hit all the other people inside that area. So it is something similar actually. Representation.
Same way data print.
No.
Most of the cases, like parallel, stop, conflict.
Yeah, but there is in that data frames don't have it don't have it have schema. It don't have distributed support. That is where Spark comes into picture. Spark also have data frames. We were talking about that.
Based on the like how many clusters.
So do you think this code is distributedly
No, there's a single
on a
single node.
single node only? So there is no backend of distributed storage, whereas your RDD or data frames in Spark that has distributed notion, right? That is where this guy ends, that guy starts, because that guy now takes care of distributed computing. Whatever in a way you're right, because what you're doing distributed processing, computation, all here, so it is working on one node. But if you use Spark data frame, it will be like you are doing in one node. You think you are doing in one, but internally it can be done with multiple. That's what. Okay. Now we need quadratic features. Okay, let's get ready for some little maths.
Let's say the prior discussion. It's like the data frame will be used from the Spark, which is distributed. Right? So here the data frame you are taking it as an input and do the processing. Okay. So you take the data from the distributed system and do the processing. And processing will be done in Python, right? Here in Stykit. Okay. So, but processing will happen in a single node, not in the multi nodes, right?
So that depends on if you are working on Spark data frame.
Correct. I'm working on Spark data.
Then the processing will happen on, depends on the backend. See, when you are using Spark, you have to run Spark somewhere, right? Right. So when you're running Spark, you may run it on multiple machines. Right. When you're creating a data frame, you will be creating a data frame. Yeah, and that can have a lot of data. So it is up to Spark now to break down into multiple. You can mention partition and all, break down into multiple machines, right? If you're doing computation, it is not happening on your local machine.
It will not happen in Python. Not on the single node.
Not on a single node. So some piece of the stuff will happen on a single node. That is known as driver piece of stuff. Okay, some piece of code will be executed on each of the other nodes. the executor nodes. That is like which is happening in parallel.
So front end will take care of Python, but in the main back end it will run on the Spark. Be it the data from input or output or what.
So the processing part, again, not all of the stuff. So as a programmer, you have to be aware that this is. So if you use a function that is collect will happen in the driver code.
Yeah.
Right.
After all the things, it will collect.
That this stuff will happen in the driver code. But if you use save as text file, it will happen on all executed. Right. So that is what the learning is there. You have to be aware. The Spark part of learning, you will get to know, okay, now this is happening in one system, this is happening in all the system. So typically your job is to identify what all things can you do in parallel. Not all you can do in parallel. Right. And if you are using machine learning, then machine learning library in Spark, So if you are using machine learning library in Spark, it will itself take care of distributing the stuff, doing things in parallel. That's what you don't have to run this like.
So for the prediction perspective, yes, on all the front-end coding will be in Stykit, but in the backend it will go on with the Spark. Not always.
No. If you are using Spark, that itself provides you machine learning libraries. Okay, and that itself will take care.
Here the question is, Spark is having built-in library MLib. So why not MLib? Why Python?
So see, this is a much richer library. Okay, much richer library. It has most of the algorithms. If you're using MLlib, you don't have many algorithms implemented as of now. It's still under development. Okay, still under development. So whatever you see Stykit algorithm, they needs to be implemented on Spark.
Right.
Okay, so and they
but there will be Scala libraries, right? MLib will be using the Scala libraries, right?
Scala libraries.
Let's say, okay, you are using the scikit-learn from Python. Similar one will be available in the Scala. Which Spark will be internally using?
Scala
has machine learning library, but it's not that rich. This is the rich. So I'll tell you one. So there is something Mahout also, Apache Mahout, right? So these are like generation. Everything is evolving. So scikit-learn is a library which is evolved the most because a lot of people has contributed. It's the richest machine learning
Okay,
library.
some of the things I might not get in the MLA.
You
so
will
that-
not get, yeah. So it's a minimalistic library now.
Okay, I have one question. Very general. Okay, if we are doing machine learning using Python, then we are using scikit-learn. Whoever is using R, but
There is a inbuilt library, but it is not as rich as scikit-learn. There is a library in Spark that does a library in R also. You will do some linear regression in R. There are some libraries that we present in R, but library is not that as rich as scikit-learn.
So you need to say for data science or data analytics platform, Python should be first preference compared to R.
Yes, if you ask me, that is the answer. But
it is also
Or part of visualization also.
yeah, visualization. Visualization actually it's very easy. If you see Matplotlib, right? There is something known as what was it? I'm forgetting. Bora, something like that. Okay, Boya. I forget that word. I don't know. So if you see that word, it will show you visualization. Boa, right? Boa. I keep forgetting. There is yeah, Boa, right? Boa, Boka. I mean, okay. I actually bad with some regional language words, so I keep forgetting it. So within that, you can actually project graph on HTML pages. You know what that means? You have a backend data, you're doing analysis, and you're projecting data in HTML page. Okay, you have seen many screens wherein you just change. You know, okay, what happens if you do this? You just drag your slide bar, right? You're getting the data there. And backend data is anywhere getting richer every day. You won't have to change anything in the code. The data will, this thing will get data from there, it will do itself, right, in the HTML. Yeah, coming back to scikit-learn, see, R also there are some libraries, okay, which is more used in financial. See, R is typically used by finance guys. Those are typically, people from mathematical background, insurance background, they are typically using R. So the R is rich in that sense that it is specific for the mathematical model. But do you think data science is restricted to finance sector now? It's not. It's now everywhere. So now you need more general purpose machine learning libraries, right? Where is scikit-learn takes a lot of advantage.
The question was like, the moment you put like a new model or predict, that time it will cursor will pass to the Spark and there it will do the processing, or it will do the processing in
No, first point.
So it will go to Spark and everything will happen, it will come back. In certain cases, if you do a fitting, it can happen in Python single model.
In certain cases, in the sense, not fitting sort of a thing. Okay. So, for example, what will happen in one node? See, there are generally two parts. I won't give it much. Two parts. One is the driver, one is the executor. So, driver generally does that piece of code which is an accumulating result from the executor.
That's the collect part.
Collection. Collect is one thing that using the result from two different data, doing the visualization.
And
it happens in your
the driver node. Right. So the moment you do the Python and Spark integration and all this predict fit, how the optimize the work? Like when you pass the control to Spark and when to do the
So this is a work that is done by Spark machine learning libraries. What you do is in that Spark machine, similarly to data frame, right? So the pandas data frame, you have the data frame, and you have, I can show you some document. Actually, give me 1 minute. I'll just show you one document. If you see Spark, and you will start like what we did is now linear regression, right? I'll show you the API, how similar it looks. Regression.
Okay, then we will use the MLlib API, not the Python API.
Right.
But on that case, then we will be losing control of this one, scikit library.
Yeah. Though, of course, if you are using scikit library again on top of Spark, you're doing a difficult job. Okay. Because there you have to make sure that that piece of code is executed in that particular mode. That means you have to write more complex Spark code.
Okay. So thumb rule is like if I go for the Python API, then it will execute in the single node. If I go for the MLlib API, then it will go in multiple. That's the point, right? And it is the developer or programmer job to identify which one is best, and based upon that we can use the
which one is best would be typically dependent on how much the data size.
Okay. If there is two use, go for the
go first. But that is what most of the companies do now. Actually. I mean, they have been doing say one system processing as of now. Okay, and the next stage is okay. I mean, there are a few trainings that I personally give where they are data science. They typically work. They know all this stuff. Okay. Now they want to deploy the same business on Spark. Because now what this is, we have grown in data size. It takes 10 minutes to get the results. 10 minutes. So you execute the result, you go for a coffee, and the program manager saying the coffee consumption is very high.
Yeah.
Right. I mean, that is what you see. It's a very common trend. He told that he gave the data. Okay, now earlier case, people used to get because data set was into GBs and all. Now it has actually gone really hard. They have high-end machines, but even that takes 10 minutes, 15 minutes time. What to do? People go for 10 minutes coffee, it goes to extend half an hour, TT table is busy, and this coffee is getting consumed more. So what is happening? We need to reduce the time so that people are more efficient. This is pure business. That is the line you said.
Yeah. So one more thing. It's like the moment you started using the Spark API, you cannot integrate that. You cannot put that code in the Python coding, right?
If you use Spark, yes. Mix and match, I don't say that it cannot be done. Of course, everything can be done, but it will be a lot more difficult.
Right.
Lot more difficult. And many times, if you're not doing it right, it may defeat the purpose.
Right.
Like let me show you this example. This is a Spark API. PySpark is a Spark Python library, and what you're doing is you're creating a linear regression model. Same API will be almost same as scikit-learn.
Right.
Okay. So now you in this entire code, is there something that is telling you that it is executing in 1 machine, 10 machine? No. You don't have to be aware.
Right.
That is what this machine learning library is doing you. Okay, and since you know this machine learning here, so okay, let me just create this linear regression from that library. So that is anyway distributed now. Okay, it knows how to do it. Now, if you are past this elastic net param, this is something we'll study actually. Okay, so here we have LR model coefficient intercept. So this is the fit. Same APIs, right?
Same
APIs. Yeah. And now if you see here, training summary, residual shows, these are like measuring
root mean square,
root mean square, error, right? Almost everything is same. So that is what is happening. I mean, same. They are now trying to port the single node scikit-learn library to some distributed computing machine.
Okay, that API also you can use it in PySpark. Still the way you are from the PySpark.
So if you want to do things very, very specific, you use scikit-learn. But scikit-learn anyway you have to learn, because you know that you can very easily understand what has to be done. Okay. Because the same library is put it here.
Okay. But Spark graphing features in Spark is graphics, right?
No. Spark graphics is not not for visualization.
Okay.
Visualization you will use same matplotlib.
Oh, okay. Then I'll come back to Python.
Graphics is to represent. Nowadays you must be hearing this sort of terms very highly. Graph databases.
Microsoft.
No, there are a lot of Neo4j is one guy. OrientDB is one guy. Not OrientDB, sorry. Neo4j is one guy. And there are a lot of companies in graph. So nowadays if you see the data, right? Data is stored in the in the older generation, or say relational database. If you have multiple tables, the relationship among data, right? One table to another table is a secondary citizen there. How do you store this relationship? In a foreign key, right? That is how so foreign key is not directly usable. Okay, that is secondary relationship. What you do in graph databases, relationship is also kept as a first citizenship. Like nowadays, data is not as unrelated that used to be before. Now, if you see social networking data, or if you see network devices data, every device is related to them, and the relationship between them is also important, and we need to store that, right? So graph databases are ways to store the relationship as well, so that you can use the relationship. So if I ask you, if you try to solve this in relational database, if I ask you, how many people will this person probably know? Which all people should I recommend this person as a friend? How will you do in your normal databases? Very complex thing. It's not that you cannot do. It's like you have to find this person related, then you go to that person is related to that person, you go to that person. That way you will do it, right? It's really complex, and the system will go for a toss.
Right.
This relationship storage can be done very simply, can be done with a very simplified manner using graph databases, where that is where graphics comes into picture. Graphics is, trust me, this is the next thing. Because the way data is evolving, you can't imagine how complex is e-commerce product relationship now. They are as of now storing in relational database. Very soon, every product will move to graph databases. Okay, and that's why if you Google few things that I'm debating not from topic. Okay.
NoSQL.
Different. NoSQL is second generation. The next generation is your graph databases.
So NoSQL is also will not be able to handle.
NoSQL is good for unstructured data. It doesn't talk about relationships here.
Okay, if you have 2%, it will store all the information about 2%. But the amount of information will explode if you want to find out how many this person related to me. So you need that relationship to be stored. Okay, so graph database, yeah. So this thing will pick up the next. That's why Spark is getting ready for storing information in graphics. That is what graphics is. Okay, graph data. So if data is in this format, you can do a little bit of reading. If data is in this format, this data is here, this data is here. How do you store the relation? And relationship is not just this guy is referring to this. It can be this guy is parent of this guy is employer of this guy.
And a back and forth relationship.
Yeah, and it can be very complicated. Right? It's you're only seeing two direction. It can be connected to this. It can be connected to this. I mean, n connection can be. How do you represent it in relation database? Very difficult, right? Yeah, but we'll go for toss, so it's not possible. Okay, we'll come back. Enough. So yeah, you can read about new 4A. Okay, just make sure, and that is what graphics is doing. Okay, come back. So. Oh, I think your friend also said something. We need to load data using. Oh yeah, you couldn't speak actually. So you can load data using Spark distributed application is an advantage to study. Is it advantage to do statistics using? Yeah, there is. This Spark MLlib is good for doing working on lot of data. Okay, definitely that is an advantage because when you have scale of the data. That's good. Not readable. Okay, so where we are. So now we'll use this polynomial regression. So what do you want to do here in using polynomial regression? Earlier days we just had the relationship that our final outcome is dependent on x, right? One feature. We are using one feature at this point of time. I'm not talking about multiple features anymore. Now what we are saying is it is also dependent on x square. Okay, so if you draw a line, y is equal to x square, what would the curve look like? It will be curvy, right? If it is y minus 2x square, it will be like this, right? So depending on what this x square and depending on coefficient before the x square, it will vary. The slope of the curve will vary. If it is 3x square, it will be like this. 4x square, it will be like this, right?
So degree 2 equals to x square.
Yeah. So degree 2, that means we are just using x square curve. So you can imagine, right? We have degree 3, degree 4. What do you have to do? You have to find various, relationship among various degrees, right? So what will you do as an experiment now? We'll do with 2 and 3. We'll see which one performs better. Understood what is happening in this case? So now, see this. We want to create a quadratic featureizer. Okay, what is it about? See, pizza.test.size is there. We have 4 sizes, 6, 8, 11, 16. Okay, so what you have to do, you have to create, what is this, this is x raised to the power 0, x raised to the power 1, x raised to the power x square. Okay, so you are creating in a linear algebra, which you have this term y is equal to y is equal to a plus bx plus cx square. Right? If you have this term, you can represent this in matrix format. How? You can represent it is
ABC format,
X, Y, Z format, right? So, right, you will have a vector with A, B, C, and you have a matrix with 1 plus x square, right? And if the vector matrix, you will get the linear equation.
But there I have a doubt. If the equation is like uniform equation, like ax square plus bx, a plus bx square, bx plus cx square equal to 0, then we can represent this one as a format way. But if it's not a uniform way, like a plus bx plus cx square equal to type or something, like normally we generally evaluate two equations, a plus bx
X
0.
There is a prediction, right?
Something else like -2. Same value as -2. We say uniform equation. This is non-uniform equation.
No, in this case, it would be a little different, right? What will be this value? This will be a prediction.
This is our prediction.
This is our hypothesis function.
Yeah.
And this is prediction. Based on the right values of let me write it here actually.
because this cyclic array, whatever we are creating, right?
Hmm.
So it is based on this condition, right? Based on this condition,
This condition, yeah.
not this conditions.
Huh?
So you have to, for this condition to satisfy, we need to do it is x square 0 x square equal to -4. This comma we need to print it. Correct?
Hmm. Right.
So based on this condition, it will should print as a 0. Based on this one only, it will plot a graph. So if you are considering -4, how you should plot a graph?
See, see, let's see this equation now. So this is something similar to what you were saying, right? This equation.
Yeah.
Okay. So understand two facts here. This is your hypothesis. Okay. And remember that your B also can be 0, A also can be 0, C also can be 0. Right? And what is your Y? Y is your prediction.
That should be x plus x square.
So this is your prediction. That means this is the value that is predicted. So for a particular feature, you will find out this x will be your say pizza price, pizza size. Okay, you will find the best value of A, best value of B, best value of C, which will predict the best value of prediction. Right? So internally, okay, to solve this, you will have a lot of data sets. Right? I think I have some slide. You have. Okay, let me just see if I have the matrix slide. Okay, though it was supposed to be covered in the next class. So what will happen? You'll have a matrix which consists of A, B, C, different values of A, B, C, right? Different values of A, B, C, and you will have a different value, a matrix which consists of 1 plus 1 by 1 comma x and x square. You'll have that matrix, and what you have to do, you have to finally solve for all the values of Y. That will be your predictions, right? So just for a moment, okay, so for a moment, what you have to do now, first stage is, yeah, so the first stage is, see this guy. So what are you trying to do here now? You are now trying to find the featureizers. So this is your one matrix, this matrix, right? Let's see now. So yeah, this is your featureizer. So this is your based on size, you're getting this entire information: x train quad, x test quad. Okay, so what is this value? This is your, for every test case, you have the entire data set generated, 1 and x and x square for every both of the test case. Is it clear? What are these two data? Right? One for test, one for, so just have it in mind. We have both the data here. Okay. Now what you want to do, we are creating this regression quad using linear regression, and we are fitting here, we are giving here x train quad. X train quad is your this matrix, and we have the price. Price is your price. How does price look like? It is one dimensional stuff, like this. So right. So what you have here is this is a matrix. X train quad is a matrix. This price is a one dimensional of same size. The price of it, and what will, this is the data that will be trained to the system. What will be the outcome? This is the data. Okay, earlier we were using only one x, right?
Only
one x. Yeah. In this case you have the entire equation, right? And you have a 1 plus x square, all the values for different data is here. What you have to find out, this our model will find out what is the best value of A, B and C, right? That is the value. If you do coefficients, you'll get that. Okay, so let
Matrix part is not clear.
how matrix part is 1 plus x and x square.
Yes, then the way you have formulated the matrix.
Why we have done it? See, you have to touch the maths. Okay, these are supposed to be there, but I will give you some hints here. Okay, which will help you through it. But this will be taught up in the next class so that the entire matrix is covered. I'll try to let me know if you are able to get it.
This video,
This is.
start video, like this.
No, going on, yeah. No, this is start video is visual screen. So, you have one matrix which consists of 1 x and x square. Okay, I think I'll get that. So I just need to show that. Then you have the possible values of the price. Okay, possible values of price. And what is the result you need here?
Each price, each sideways price.
What is the result you will get here? You will get here that
A, B, and
X. You get well for X, right?
you will get the coefficients A, B, and C, right?
Now, how will you get the coefficient?
Based on calculation of X. So,
So-
you can find the X, right? Based on that.
So if it is a two degree equation, then that formula is there. B equals to minus B plus or
I have
minus
the
4.
slide.
B square minus 4 is equal
There
to
is a slide on matrix. Give me a minute. The diagram is easy to explain. Matrix.
2 degree, you can solve it.
Give me, I think in my other system it is there. Just see the diagram. It will be clear, and how to do the maths it will be taught in the next class. Okay, just see that.
Only solve program. Only X or any school maths for example, तीनटा वेरिएबल्स है वेट में तीनटा है ना तीनटा है उसमें हां मैं सुन x प्लस cz है अगर वैल्यू दोनों की चेंज से असाइनमेंट है तो वो भी 0 कंसीडर 0 सो we can simply consider a b c consider which is so it also is it 0 वेक्टर तो 87 में देखो हमको with respect to A, B, C, हमको रिलेशन बचा है इधर कितना होची फॉर्मूला A, B, C फॉर्मूला करको इधर 0 है छोड़ दे दो ऐसा वेरिएशन में स्क्वायर रूट्स है ये 0 है नेक्स्ट को हम एटा को सब पॉलिनोमियल लाइक पाइवट करके एटा 1 करे चेष्टा करें एटा योग वैल्यू एटा 1 करे चेष्टा करें एटा 0 करना ये 1 0 0 0 pivoted format असला में এটা হলো নল স্পেস ক্রিয়েট करना यहाँ पे नॉल स्पेस क्रिएट करना और बाकी जो व्यक्ति रहेगा BC तो BS जीरो से कैलकुलेट हो वो कंफर्म এটা খালি कंफर्म कर देते हैं वो ठीक আছে मोटे कोफिशिएंट
and X, Y, Z to have
X और
X, Y, Z available.
डेटा है तो डाउट है कोफिशिएंट
Okay, so these are the things that will be, eventually spoken about. Okay, so here I need to, okay, this one, see this. This is something similar. Okay, these. Suppose take an example of this case. Okay, this is y is equal to mx plus c. It's also represented same way. In the other case, you can imagine. So this is different values of different hypothesis, right? Different value of a, b, c, right? You'll create a huge matrix with all possible values of a, b, c, a, b in this case. This is so. What you're doing here, this minus. This is your first matrix. This is 1, 1, 1. Okay, and since you are converting into two there, and this is your pricing. This is your house size, right? This is the matrix.
This house price or size?
House price. Sorry, size. This is house size. You have to devise the best AB, which will predict your best house price. That is the objective, right? No. Okay.
Price was 200 per
Forget about, huh? No, size.
this.
This example, just say this example. Look at this house price, house size. Okay, this house size. This is your various competing hypotheses. Understand how competing hypothesis system will find out a lot of hypotheses, and he will compete and will get the best out of it. This is various hypotheses. So in here you have various combinations of A and B. Okay, just imagine with C also here. Just imagine for a moment, just for this time, that you have some x square, a c value, right? A, B, C, all this data is there. Okay, and this house size is there. So what you do here, you have this combination. Okay, and you have this combination. This is your what?
This is your that equation form.
Equation formula, right? 40, 20, 40, 200, 150. This is coming this way. Right, then you have 0.25, 1x, and 4 this way, right? So you have values. So if you have 4 variable, it will be again like this here, right? And eventually you are calculating these values. This is the prediction for first. This is this data. This data is this prediction for first for this guy. This guy is prediction for this guy. This guy. This guy is prediction for this third guy. So now you have this matrix. Using this matrix, you will figure out which one is best. Right? So the same thing we have to extrapolate here.
So we are doing this category, this part, not zero.
Not zero part. Zero actually zero is like no cost.
Yeah, no problem. Okay,
Right. Understood, right? So this is how those details about this will be taught to in your regular class. Yeah.
Out of these three values, the three matrices, which one to predict means how to know which one to.
So you have these values. This is for the first guy. Okay. So what is these values? This is price for house of this size. 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 Okay. Now you have, these are the pricing for different house size. Correct? Now what will you do? Now you have actual data sets. This is a prediction based on different data. You have an actual data set. You will find the difference between actual price and this price, and you will find the square and your jobs.
Same like as normal regression, but polymer fitting will be split into a single format, and each single format should be calculated.
So if it is similar, it is easy for us to calculate in mind. Just that if you increase one more dimension, it will be just 1/4 factor here.
Yeah.
The matrix that you keep on increasing.
This guy will keep on.
But in real cases, means future cases, the The actual price will not be there. So how to find
Yeah.
out? How to
So in future days, based on your training data set, you have figured out, okay, this model is best. Based on training data set, how you figure out?
Suppose, okay.
No. Suppose in your training data set, okay, we
got
got
that.
RSS training RSS what you got, right? You figure out this is the best. Now, if you figure out this is the best, what was the best AB? It was this and this, right? Now, using this and this value, you will predict in future for your test data cases. These are trained data cases output. For test data case, you will use the same.
So we have to take this.
We'll take the second one.
We'll take the second one and we'll predict the results. Then there's multiple levels of checks as you can see. First is your prediction, trained data test. Then your tested data sets. Then you have multiple models that level of testing. Okay, there is no that hard line, but you have to continue do this thing, test it. Continue do this thing, test it.
More number of features will add more control.
Is there any concept of correlations in equations in this type?
There is a concept of correlation.
That we are covering in regression part.
Now, in gradient descent part, not that I'll be covering mostly. Are you going slow? Because I wanted to cover some topics, we didn't reach it here. Okay, so in gradient descent, we typically will cover, how to figure out which is the lowest cost. Okay. Maybe I think initial there will be a lot of Q&A, so it will take. Okay. So yeah, so we'll figure out. See, if this part is clear,
Yeah, this part is
this
clear.
part I can go ahead.
Yeah.
So let's come back. Let me quickly go through it, and after the code is available, so you can try. Okay, so you have quadratic featureizer. Okay, using this fit, I think you understood now, right?
Yeah.
How this entire thing is done. Using fit, you find the best model, and using the best model, you will be able to predict. And please do this, and to understand if the performance has increased or not. You will definitely see an increase in the performance, because you will be and project this graph. That with one normal linear regression what is showing, and polynomial linear regression what is the graph. Okay, project this sort of a graph. Okay, and see this thing that it should improve, right? The performance should improve. Got it, right? Okay, so try this stuff. This is anyway available. There is the fancier part was just creating a featureizer here, and you understood, I guess, what is the benefit of it, how the maths is done.
The feature is like a predictive matrix.
So that's it. Okay, and do one more exercise. Please note it down if you want. Okay, this is for x square, right? Try it for x cube. Yeah, and typically what you have to change. Just one variable you have to change.
Polynomial with
X square, x cube, and see which one is performing better. Find this code for. Okay,
And which data?
Yes, that is the answer I was about to give. So do this not on the PISA data set, on some real world data set. I'll show you something. Yeah, so in here, either do you guys want to find your own suitable data set, or should I recommend?
This one.
No, this one has a lot of data set. Okay, so
Take message.
Actually, some of the data sets, those are only few data. I don't know which one to pick.
oh, is it? There are a lot of companies data actually.
That's what we recommend. So we recommend some can get to
So there is
No, what's only one thing. Like whatever assignment you are giving, right? Just give us assignment like that, like end of this course, right? It should be considered as a project.
Yeah, so this is what actually. So as I was discussing with you, right? I want to develop a product, and of course, no revenue interested, but you don't know. So it will be like there are a lot of companies. This is one website. There are a lot of Indian companies, Indian initiative because of digitization and all that. A lot of data is Aadhaar data is API is government. I have that record actually. So government APIs are available. Okay, using which you can develop apps. Okay, or website which will, if you give query, it will find Aadhaar data. All these APIs are available, public open APIs. So you can actually use that as well, which I will show eventually. So now I think you can use this education data. I don't remember this. Companies that I have seen. So there is I have education. So teachers position in different categories in provisional data. Actually, these are school class-wise enrollment of different categories. I think this is something useful. So this is your 30th September. What is the difference between 8th and 10th, right? Right. So your data will not consist of only one Excel sheet. Got it, right? It will be 1 to 10. Right?
So you have to manually.
No, manually you don't have to. You don't just download it from here. All the data in CSV format. Then in Pandas you can load the entire directory. Okay, just to see how to do that. In Pandas you can load the entire directory and all the in at least GraphLab have it. So Pandas also should have it. Actually. You can load the entire directory. All the files you should be getting it. So you can do the processing, or you can load different files for different, and you can merge the data. Where your data. So it will spend some time. It's not that it will happen in 1 2 hours. Okay. So what you do is you get through this data. Let's just see the data so that I can get it. Then I've also not seen this data. I think this is something useful. Different state-wise total enrollment in different information.
It's a CSV file, right? Then you can open an Excel.
I don't think I have Excel sheet in my machine. So I have put it in cloud and I. Yeah, so that's okay. We can load it in our this guy itself, Pandas, and we can use head to see all the contents. Okay, and we have different states. So do this, okay? Using this information, so do you have dropout information as well? What is it? Girls enrollment in class 7? First, do this. First is using this various states. This is for which year?
Class 6.
Class 6 to 8 in urban area. Okay. In September, class 9 to 10. Okay, different area. Rural area. Oh, you have urban area, rural area. Okay, all this information is there for different classes. 8, 9, 10, 11 is here, right? So let's see the next page. 11, 12. So you have 8, 9, 10, 11, 6, 7, 8, 9, 10, 11, 12. All this data you have. So first, using the data, so we typically have some school information here. Using the data, first you do one thing. First, predict how many people are. Assume that you have college after this. You have to predict how many people will go to college, right? Or how many enrollment will be there in college. So you have given this data set. How many enrollments will be happening in college? I'll just share the link.
Always okay.
So how many features will be using? So what are the features will be? Only one or two variables will be taken out.
That is your decision.
I can take any.
See which model works better. One model, multiple model, polynomial regression, which is working better. You have to find out the best model which works better.
I can use only one feature and do it. That might.
But if it takes 2 features and does better than you, then.
Oh, so that's the only
Yeah. So yeah, got it right. So I mean, try.
But I think more features. And so it will become totally complex.
So you have to prove it and
Okay.
make sure you're storing all the information. Okay, you do this much data. This is going bad.
Oh.
Okay, so you have to take a call. I mean, you can yourself decide it when this is relevant. Like we have some information over there state-wise. Okay, so
With the state is repeating.
so
then you will know
feel
what
free
it
to
is.
reply in this group chain. Even I will have to take a look. I just saw it now. Okay, so this is one data. Just do the little bit of analysis. Okay, this is how the data look like. Okay, just reply to that group.
Maybe we have to create some communication channel.
No, you can use the same mail group, right? Wherever you are, reply to that. And I think I was mailing it from my thing, right? Yeah. Yeah, it's varying it from my ID. My ID only, yeah. So make sure you just remove the group ID because unnecessarily that will be. Group and support.
Your mail ID is there.
Yeah, I will take, yeah. Okay, I think everything is else is fine, but support should be removed from here.
But if your support I will remove it.
Because unnecessary.
Your mail ID is
My
there.
mail.
I think I am not in that mood. I am not getting a mail.
So your
just
deadline last.
Pratyush Acharya, right?
You sent this? Okay, so support mail I got. Did you send me?
Yes.
But that's okay. I mean, you're getting that mail, right? I'll pick it up from here. Support.
Actually, yesterday only I got it.
Yeah, coming back to got it, right? So just we'll do some analysis and we can find the best model to predict how many people will join college, that sort of thing. Let's now come back to what do you say, gradient descent. Okay, let me try quickly explaining it. Okay, so what is the, just see one aspect here. What is differentiation? What is that? So what is acceleration? It is differentiation of speed. E by dx of speed is known as acceleration. So what is differentiation? Technically, it is a rate of change of something. Okay. So what is our objective with gradient descent? Okay. The objective of gradient descent is to find the function. Like you remember in the matrix we have all the results. Cool. But how do you find? And we just discussed how do you. He was asking, right, which is the best model. So I just told him that find the difference of the cost and you will find the best model. But think of millions of dimensions, right? Millions of size. It's impossible to do that in real time, right? So what is the objective now? You have to find from a n-dimensional stuff. Okay, the objective is to find that particular point. Okay, and that particular element which is low cost. That is you understood what is wrong here, because if you have a huge matrix, okay, n dimension, the 4 dimension, you have to find the point which has least value. How do you do that? You cannot do scan and find it, right? It will take a lot of time. How do you do that? For that you have gradient descent to find the element which find, like in this case, suppose this is the 3-dimensional matrix. Okay, what do you have to do? You have to find the theta 0 theta 1 for which the cost is least. Is j theta 0 theta 1 is your cost. What is j theta 0 theta 1? It is your every model's root mean square, right? Whatever the equation is now, that is theta 0 theta 1. So to find the correct value of theta 0 theta 1 which is least. Okay, so gradient descent works typically in 2 steps. Okay, it will start with any theta 0 theta 1. Okay, and keep changing theta 0 theta 1 to reduce j theta 0 theta 1. So what you can imagine as this is a 3-dimensional figure. Imagine this. This is your j theta 0 theta 1. So we start with any theta 0 theta 1. Now from there, so imagine this is hill. Okay, hill. Okay, you are at the top of it. You have to go to the deepest point from your point. Okay, you find which is the surrounding you. You'll see which is the point at which it is going more deep. You'll go towards that point. Same algorithm is done. Okay, then after reaching there, you see which is the place. If you go there, I'll go more deep. That is stuff here. So you use the same concept. Okay, so what do you do here? But again, remember, if you are starting with different points, you may go to different deeps, different directions, different. Your low cost may be different. Okay,
What if we have two places with the low cost, same low cost?
Two places, one of them will work. Does it really matter which one is the result? Because both of them are giving same outcome, right? Right? It is possible.
Is this a manual process?
No. This is what software does it for you. Okay. See.
Anyway, he will find out the list.
See, this gradient descent is a mathematical concept. Okay. So here, what it will do, how this is used in linear regression. Linear regression finds the cost, right? Now you want to find the lowest cost very quickly. Okay, so very quickly, if it doesn't make sense, if that is taking a lot of time. So that is the method of linear, that is the method of gradient descent here. You have to find the low cost very quickly. So now, what you have to do here, see, what is gradient descent? You have to find theta, the best combination of theta 0 and theta 1. Okay, suppose you have to find best combination of the best. J can be, in case of 2 dimension, 2 variable, J can be theta 0 or theta 1. One of them both. Okay, so J can be one of them both, theta 0 or theta 1, right? Now, what you are doing here, this alpha that you are seeing, right? It is the learning rate. What is learning rate? When I'm in the hilly area and I have to go down, it is the step size that I take, right? Step size that I take. That is your learning rate. That means to find a particular lowest cost, how much jump you are doing. You understand this is low, but you are doing the jump here. It may so happen that it is actually little low, but it is more up. So you might come up also. The jumping is too high. Jumping size is too much, right? So this is your jumping rate, and this is your jumping rate theta. This is your current value of theta. Okay, this is the new value of theta. That means whatever direction is the new value of theta. This is current value of theta minus jumping rate, size of the jump, d by dx of j theta by theta 1. What is j theta by theta 1? J theta by
The first one.
the root means the cost, right? The j theta by theta 1 is the cost. So what are you doing? You are doing d by dx of the cost. What does that mean? Rate of change of cost.
Means all small changes based on the theta j, based
Right.
on our assumption.
Right.
And we are just dividing to take the variances.
Right. So in a curve, what is d by dx?
Stable.
Exactly. The slope, the tangent to that. At a particular point, d by dx is tangent to the curve at that particular point, right? So when you're doing d by dx of that the cost, you're finding the ratio of change. I'll show you this with a very small graph. Acha, see this diagram. Okay. So now slope here is more than the slope here, right? How to represent this? This is represented by d by dx of cost. This is a cost curve. Okay, this is in this direction. It is cost. It is value of theta 1. Okay, the cost here is very steep, right? So the tangent will be very steep. So d by dx will be giving a higher value or more value. Okay. Now I'll come to the positive negative aspect later, but it gives you a more value when you are at this point, and it is a negative slope. Change will be more. No. Understand two aspects. It is a negative slope, isn't it? The slope is in this direction. This is a negative slope. So it is a minus of more value. Minus of more value. So we'll do alpha into minus of more value. It will be more minus. And what is the equation? Minus. So minus plus. So what will happen to the theta 1? It will increase. That is why it will go towards this direction. Positive direction. And that is because your this point is here. Right? So that is the reason why you will go in this direction.
So a point will come where it will converge.
Yeah, and gradually you will see your learning rate is same, but d by dx the slope is reducing. So you will take, you will gradually come here and reach it. Suppose you are starting at this point, this theta value. Because as we discussed before, theta can be anything. You are starting at this point. Now what will be your slope? Positive slope. So your minus positive. So your theta will be reducing. You will be coming this direction. This is happening only in one direction, one theta. Right? You can have n theta. right? And theta that means it will come with, after the theta becomes 2, it will come like, you know, net sort of a diagram that we have, right? It comes like this.
Yeah, it's like the alpha, sorry, yeah, say alpha value, that constant value, whatever we are defining, how is it defined?
Alpha, I'll tell you. So this alpha value is very, I mean, there are actually ways by which you calculate alpha, but there are two important steps actually I have in the slides. It contains how do you choose alpha, right? If the alpha is too small, it will take very big steps. Okay, it will take a lot of time to converge. It will do that, but it will take a lot of time. That's not the gradient. If alpha is too large, okay, there is a problem. If you do this right, you will see this. If alpha is too large, then what will happen? Your step size will be too much. So you might think, okay, this is the closest I should go there, but your jumping size is same. You might actually climb up. So your rather than your cost function coming down, it might go up, right? Then it will stop. Actually, that is what the software does. It will stop. It will change the value of alpha. Okay, it will do this.
Okay, it will change the value and again
it will do. Okay. A lot of things you don't have manually have to do. It will the software, if you're using gradient descent, it will find the best value. Okay, so that is where.
So gradient descent will work for both the cases, single as well as
Single, the graph is simple. Polynomial, you can't imagine the graph. It will for two variable, it will be like net, right? But 3 variable converge, it will be that hyperdimension. Okay, so now if you see the gradient descent, now that you understood what is gradient descent now, right? Now if you apply gradient descent to your linear regression, what is the objective? You have to see, this is your linear regression model, 1 by 2m sigma of this entire stuff. So this and so what is happening here? You'll have to replace the j theta. This is your cost, right? Okay, this is your cost. So d by dx of, and you'll replace this j theta by theta x with this entire equation, right? This is the cost equation. If you do d by dx of this entire stuff, you will see this d by dx of 2x square. What is it? 2x. 2x, right? 2x. So that's why this 2 will come here. It will nullify this 1 by 2. That is the reason why we do 1 by 2.
1 by 2,
right? Then m was for mean that time. Okay, so that thing is there. So if you do the maths, eventually you will get like this 1 by m. Okay, for when theta is equal to 0. When theta is equal to 0, what is the value of x? X was 0 when theta is y is equal to mx. See, the x was 0 in that case, right? Constant. So it will become like this. There is no constant. If you are doing it, if you are doing d by dx of this with j is equal to 1, that means the first term, it will become like this, x. Okay, if you do the differentiation, you will get it here. And eventually the equation looks like this. Okay, one point here. So remember, here it is in red, theta 0 and theta 1 should be simultaneously changed. It means you should not use the update new value of theta 0 to calculate theta 1. You should change both theta 0 and theta 1 based on older value. Okay, get the new theta 0, theta 1, then calculate it. Because that is what you have to do, right? At every stage, you have to find the new theta 0, theta 1. Right? So that is where.
Not a single value.
Both of them. That's why you have this guy. Yeah. See this. First, you will calculate theta 0, store in temporary variable, theta 1, store in temporary variable, then you will change theta 0, theta 1. Because if you change theta 0, theta 1, this guy will also change, right? So you should do, I mean, I think it's very intuitive. Okay, should not change one thing intermediate. I mean, they say that it was. Okay, but I hope it's interesting or
so next weekday class we will do Wednesday.
We will do what time?
9, evening 8:30 or something.
1 hour.
Can we do it on Tuesday?
Yeah, that's
I will just actually traveling. Tuesday.
Is it on Thursday?
Either. Yeah. Let's try it on Thursday.
Thursday at 8:30.
Thursday to 9:30.
You'll be available. Okay. Okay.
Only just share all this.
Yes, I'll do it. Actually I have uploaded a lot of them, but it's in another. Yeah, videos. Yesterday I did that.